This is lesson 4 of module 5 on exponents and exponentials. And at the end of today's lesson, you'll be able to raise a power to a power and also to raise a product to a power. So we're going to start our lesson by taking a look at the following chart. And we're going to break down what each exponent raised to a power, and then in parentheses it's raised to another power. We're going to see what exactly that expands out to so that we can generalize and make a rule. So if you think about the quantity 5 squared raised to the third power, that's 5 squared times 5 squared times 5 squared. So if you break each 5 squared, you have a 5 times 5, 5 times 5, 5 times 5. That's 6 5s altogether. So that would be 5 to the 6th power. Now, in our next example, we have -3, the quantity squared, and we have that raised to the second power. So I would have a -3 squared and a -3 squared. So each one of those represents its own -3. And there's 4 of them altogether. So we can rewrite that as -3 to the 4th power. And again, with b squared raised to the 4th, that's b squared, b squared, b squared times b squared. So there's 4 b squareds altogether. And break each one down into a b times b, b times b. How many b's would there be? So that's 2, 4, 6, 8 b's altogether. So that breaks into b to the 8th. So you can kind of notice here with the 8 and the 2 and the 4. Then here's a 2 and a 2, and that makes 4 altogether. Here's a 2 and a 3, and that makes 6 altogether. So when it says, do you see a shortcut that could get you from the original problem to the answer without the 2 middle columns, I'm hoping that you're noticing a pattern that you can multiply the original exponents. And that's where we get into our power to a power rule. So the property is raising a power to a power. If I have some number raised to a power and then another power outside of the parentheses, I can get my final answer by multiplying the 2 numbers. So let me show some teacher-led examples. Here we have an n to the 4th power, and that quantity is raised to the 7th power. So I'm going to show my work like this. N to the 4th, 4 times 7, final answer, n to the 28th. And again, with x to the -3rd raised to the 5th power, power to a power, the rule is you multiply. So that gives me x to the -15th. And then I do have that rule about never having a negative exponent. So I would go one step further and I would put that into the denominator. So what happens if I have an expression that has some powers raised to a power and others that are not? Well, you can see here just the y to the 5th is raised to the -2nd power. So the y to the 3rd doesn't have anything else being done to it just yet. So I'm going to do y to the 5 times -2. So y to the 3rd times y to the -10th. And now I go back to the rule from a couple of days ago. When I have exponents of the same base that are being multiplied, for those two guys we add. So 3 plus a -10 is -7, and I think I'm done, except can't have a negative exponent in my final answer, so I will put that down to the denominator. So this one problem, we kind of used all of our rules. We had power to a power, so we multiplied. We had products of exponents with the same base, so we added, and then we had a negative exponent. So Here we have some now it's your turn problems, a little combination of everything. So these are your try it problems. Go ahead and pause the video and see what you can do with these. Use a pencil just in case you have to erase and correct yourself. And we'll check our answers just as soon as you unpause the video. Okay, so welcome back. Hopefully you paused the video and you tried these on your own. So I'm going to show all of my steps. First of all, I've got a power to a power, so I'm going to take care of that first. 6 times negative 4. Which is negative 24. Then product of exponents with the same basis, so I add. So x to the 2 plus negative 24, or x to the negative 22. And I'm going to put that down to the denominator. Final answer 1 over x to the 22nd. Next problem, once again, here's a power to a power. So I've got w to the negative 2, and then times w to the 7 times 3. So here's w to the negative 2 times w to the 21st, and now we add because we're multiplying, but see how I have the same bases, which are both w, so that rule is that I add negative 2 plus 21. I get w to the 19th, and since that's a positive exponent, I'm good to go. I'm good to leave it just like it is. And the last one, power to a power, so I multiply, and eventually I want you guys multiplying these things in your head. We've got r to the negative 5 times negative 2, which is r to the 10th, times r to the 3rd, r to the 13th altogether, and that's my final answer. So in the next table, which goes over onto the next page, we are going to explore by completing the table and answering the questions. And notice, the last table was titled Power of a Power. These are called product to a power. So I want you to notice inside my parentheses, I don't just have m being taken to the 3rd. The 4 is also being taken to the 3rd. The whole expression, 4m, the whole product is being raised to the 3rd. So we can expand that out by writing 4m times 4m times 4m. And commutative property says I can go ahead and rearrange the 4's and the m's and put all the 4's together and all the m's together. So that's 4 to the 3rd, m to the 3rd. And using my calculator, 4 to the 3rd is 64. So as a final answer, 4m raised to the 3rd is 64m cubed. So let's take a look at a few more. I've got an ab to the 4th, and let's go ahead and expand that out. I've got an ab times an ab times ab times ab, or 4 a's and 4 b's. So I end up with a to the 4th, b to the 4th. And there's nothing really to plug into my calculator, no numbers involved, so that's really my final answer. But here when we have 3xy squared, really you're basically saying you've got 3xy times 3xy, which if I rearrange it, I have the 3 times 3, the x times x, and the y times y. 3 squared x squared y squared, aka 9x squared y squared. So the numbers, you can actually put them in your calculator or multiply in your head and work out the math. The exponents are still going to follow the rules of exponents. So when it says do you see a shortcut that could get you from the original problem to the answer without the 2 middle columns, when you paused the video, did you fill that out? Did you write down a rule that you thought you could use? So I am going to use this word, distributive property. Just distribute the exponent to each piece in the parentheses. Just distribute the exponent to each piece in the parentheses. So, raising a product to a power, let me give some variables there. If I have two things being multiplied by each other, or any number of things in parentheses, and all of them are raised to a power, then I can distribute that power. So a to the n and b to the n. So let's take a look at our example, which has some somewhat complicated products and being raised to different powers. So here, when I have an exponent and a parenthesis and another exponent, that tells me when to use that power to a power rule. So for n, I'm definitely going to be doing 5 times 2. For my next product in the parentheses that's all to the third power, I want to go ahead and I'm going to do 4 to the third, m to the third, because m is really to the first here. 1 times 3 is 3. And then n gets to be to the -2 times 3. So I'm definitely not finished here. I have too much stuff expanded out. So here I've got n to the 5 times 2, or n to the 10th. And then 4 to the third, we saw on the previous page, that's 64. M to the third, n to the -6th. So hopefully you're noticing that these n's can be combined together. They're a multiplication problem with all one base. So I want to do 10 plus -6, which is 4. So I'm going to still have my 64, my m to the third, but my n is 10 plus -6 equals 4. So now it's your turn to go ahead and attempt to simplify these 3 problems. These are your try it. Go ahead and pause the video and see what you can do with them, and we'll check our answers in a bit. Welcome back. Hopefully you've paused the video and you're working out or have worked out your problems. I'm going to go ahead and show my work here. I have x to the -2 times 2. That's a product, power of a, or power to a power. Here I've got 3 to the 4th, x to the 4th, and y to the 5 times 4, or 20th. So now I can take my number value, 3 to the 4th, and that's going to become a coefficient, so that's 81. X to the -4 plus 4 is 0. X to the 0 power is just 1, so I don't have to write it, and y to the 20th. Next one, I've got 6 to the 3rd, a to the 3rd, b to the 3rd. And then here I've got 5 squared, a to the -3 times 2, or a to the -6. So 6 to the 3rd power, that's going to be 216. And then 5 squared is 25. So I'm putting all my numbers together. A to the 3 plus -6, and b, looks like I just have one b to the 3rd power. So my number part is 5400, a to the -3rd, b to the 3rd. And last but not least, I can't leave that negative exponent. So 5400, b to the 3rd on top, with a to the 3rd on the bottom. And last but not least, I've got 3c to the 5th raised to the 4th power times c squared to the 3rd power. So I'm going to distribute this 4. So 3 to the 4th, and then c to the 5th to the 4th, that's power to a power, so that'll be to the 20th, and then c to the 2 times 3 is c to the 6th. So working out my numbers, 3 to the 4th is 81, c to the 20 plus 6 is c to the 26th. So in summary, we learned how to take to do power to a power problems. And if we have a product or two things being multiplied, we now can take a product to a power. Thanks for listening.